Hello, and welcome to my video on arithmetic sequences. This video has 5 objectives. First, students will be able to define and recognize an arithmetic sequence. Students will be able to write a recursive formula for an arithmetic sequence, as well as write an explicit formula for an arithmetic sequence. Students will be able to find any term in an arithmetic sequence, and finally, students will be able to determine if a given value is a term in an arithmetic sequence. So let's get started. First of all, an arithmetic sequence by definition is a sequence whereby a constant amount, or in other words a fixed amount called the common difference, is added to get from one term to the next. The common difference is represented as d and may be negative for sequences that are decreasing in value. The key piece here is that in arithmetic sequence we need to add the same amount consistently to get from one term to the next. You can see that here where we have the recursive definition for an arithmetic sequence. A sub n plus 1 equals a sub n plus d. What we're really saying is to get the n plus first term, we'd have to take the term right before it, which would be a sub n, and add a d onto it. Looking at this example, the sequence 8, 12, 16, 20, 24, 28, a sub 1 is 8 because our first term is 8, and d is 4 because we're adding 4 to get from one term to the next. In the sequence at the bottom of the screen, 14, 11, 8, 5, 2, negative 1, well now our a sub 1 is 14, and our d is negative 3 because we're adding negative 3 to get from one term to the next. Again, we need to be in the mindset, how much are we adding to get from one term to the next term, the term to the right. Here I've written out the first 4 terms of a sequence, called them a sub 1, a sub 2, a sub 3, and a sub 4. Well, of course, a sub 1 is a sub 1. But in an arithmetic sequence, a sub 2 is a sub 1 plus 1d. If I took a sub 1 and I add d to it, it moves me one term down the line, which is to a sub 2. A sub 3 would be a sub 1 plus 2d's. Because if I take a sub 1 as my starting point, the first time I add d, it takes me to a sub 2, and when I add d a second time, it takes me to a sub 3. And if I'm at a sub 3, and I add another d onto that, now I'd have a sub 1 plus 3d. Well, that would be the 4th term of the sequence. You will notice that the subscript is always 1 more than the coefficient in front of d when we're using a sub 1. Said another way, the coefficient in front of d is 1 less than the subscript of the term we're seeking, which leads us to this definition, and you'll want to copy this one down. A sub n equals a sub 1 plus the quantity n minus 1 times d. And again, what we're noticing is the term we're seeking, n, the coefficient in front of d is 1 less. We have n minus 1, which is 1 less than n. Let's take a look at this specific example. Say we take the sequence 7, 11, 15. We're going to want to do 5 things with it. For the A part, explain why this is an arithmetic sequence. Well, think about the definition of an arithmetic sequence. Are we adding the same amount to get from one term to the next? Yes, it looks like we're adding 4 to get from one term to the next. So we could explain it in the following fashion. The sequence is arithmetic because we always add the same value, in this case 4, to get from one term to the next. In other words, there's a common difference among the terms, and it is 4. Write a recursive formula for this sequence. When we write a recursive formula for any specific sequence, we're going to need 2 things. We need to specify any term of the sequence, and then we need to give a recipe to get from one term to the next. Most often, we give the first term of the sequence. That's pretty conventional. So a sub 1 equals 7. And then here we're saying to get the n plus first term, take the nth term and add 4 onto it. Because again, in this sequence we're adding 4 to get from term to term. So to get a sub n plus 1, take a sub n and add 4. The problem with the recursive formula is, if I wanted the term, say, a sub 100, I'd have to let this n be a 99 in order to get a sub 100. And then this n would also be a 99. So a sub 100 would equal a sub 99 plus 4, but the problem is we don't know the 99th term. So we'd have to use the same formula again to get the 99th term, in which case I'd let n equal 98, because 98 plus 1 would be 99. Well, a sub 99 would equal a sub 98 plus 4, but I don't know a sub 98. To get a sub 98, I'd take a sub 97 and add 4, which I don't know that one either. Pretty soon you end up rewriting the entire sequence, hence the term recursive, from the term you have, a sub 1, to the term you need, a sub 100. We don't really want to write out 100 terms to find a sub 100. There's a better way, and that's the explicit formula. And that's what we're asked to do in the C part. Write an explicit formula for this sequence. All right. So here we go. In this sequence, remember a sub 1 was 7 and d was 4. We're going to substitute into the equation from the previous page that I told you to write down. A sub n equals a sub 1 plus quantity n minus 1 times d. If we substitute in the 7 for a sub 1 and the 4 for d, and distribute our 4 and combine like terms, a sub n would equal 4n plus 3. And this formula is an explicit formula, and it allows us to jump to any term we want. So say we really did want to find the 100th term of this sequence. Well, if we use the formula that we arrived at in part C, it's no problem. What we're going to do is substitute in 100 for n into the equation a sub n equals 4n plus 3. So a sub 100 is going to equal 4 times 100 plus 3. In other words, 403. We didn't need to find the 99th term or the 98th term or the 97th term or any of the terms. We could go immediately from the first term to the 100th term, because that is the power of an explicit formula. And finally, is 501 a term in this sequence? Well, what I want to do is set our formula a sub n, 4n plus 3, equal to 501, and then think about the value of n. Since n is our subscript, and our subscripts can only be counting numbers, 1, 2, 3, it's going to be important that n would turn out to be a counting number, or a positive integer, if 501 is a term of this sequence. So, take our formula 4n plus 3, set it equal to 501. And our first step would be to subtract 3 from each side, leaving me the equation 4n equals 498. Then divide each side by 4, which is going to leave n to equal 124.5. The conclusion, the 3 dots in a triangle mean therefore in mathematics. Therefore, 501 is not a term of this sequence. Since n is 124.5, what we do know is 501 lies between the 124th and 125th terms, or between a sub 124 and a sub 125. Well, there you have it. You're now an expert on arithmetic sequences. I'm Murray Wright. Thanks for watching.